Okay, this is a solution for easy problem number 2. You've got two balls, you're comparing the velocity of the two balls. One of them is thrown upward, which is our red ball, and one of them is thrown downward at the same speed as the ball thrown upward. So we've got two situations to model here. For part A, they want to compare the velocities right before you hit the ground. So I'm going to model both of those balls, and we'll do the red ball first. We're a 40-meter cliff. The red ball is starting at the top, and my second point is at the bottom. I'm going to define my origin at the bottom, so the positive y direction is this direction. So this would be a y of 0, this would be a y of 40, and the red ball is thrown straight up at 30 meters per second. So I have a starting velocity of 30 meters per second, going upward, and if we start filling in our values, I know my initial position here. With my origin upward, I'm at 40 meters. My velocity to start is upward as well, so it's a positive 30 meters per second. My acceleration, we're in free fall as soon as he releases that ball, so we're at 9.8 meters per second squared, and my time, we're going to call it time 0. At the end, my y value is 0 meters. I don't know my velocity, that's what I'm going to solve for. My acceleration through this whole trip is a negative 9.8 meters per second squared, and my time we don't know either. So to solve for my velocity, I'd use this equation, final velocity squared equals my initial velocity squared plus 2 times my acceleration times my displacement. And if we plug in our values here, my final velocity is going to be equal to the square root of my initial velocity, positive 30, squared, plus 2 times negative 9.8 meters per second squared, times my displacement. And now my displacement, you want to look where we start and where we end. We have a negative displacement, final minus initial, so 0 minus 40 gives me a negative 40 meters. And that causes both these negatives to cancel, so I can take the square root. And if you do take the square root of that, you get positive 41.03. Anytime we use this equation, you want to be aware that I'm squaring both my values, so you have to go back to my problem. I am going this direction at the end, so my velocity is actually a negative 41.03 meters per second. So that's the velocity of the red ball. To get the velocity of the blue ball, I'll make a second sketch. We're going to find that it's going to be the same sketch, top, bottom, we're still 40 meters. I'm going to define the same origin. This is my positive y direction. And this time we're throwing the ball downward. The only thing that changes in this problem, if I scroll back up to the top, is my velocity here goes from a positive 3 meters per second to a negative. So all the values are the same. I'm going to go ahead and fill those values in. I'll be right back. So here we are back with all of our values filled in. The only thing that's different is I have a negative velocity going downward. To start, use the same equation to figure out our final velocity. And I just pulled that from the top here. So we're the square root of our initial velocity squared, which is a negative. And if you square a negative, you'll see that we get the exact same value here that we did above. This is all the same. So our answer is exactly the same. And our final velocity is 41.03 meters per second. Again, if I'm using this equation, I'm squaring. Go back to our problem, we are headed downward, so this is a negative 41.03 meters per second. So the answer to part A is they are the same velocity before they hit the ground. Okay. How much later does the red ball hit than the blue ball? Now I'm going to do time. I would get the time of travel between these 2 points by using this equation. My final velocity, which I already know, I just solved for, is equal to my initial velocity plus my acceleration times time. I know everything in this equation except for my time, so if we fill that in, my final velocity, negative 41.03 meters per second, equals my initial velocity as a positive 30 meters per second in this problem, plus negative 9.8 meters per second squared, times time. If you solve for time in this top one, it comes out to 7.248 seconds. So a long time for travel. Use the same equation on the bottom. We'll get time for travel here. My final equals my initial plus acceleration times time. If we fill in our values, same final, 41.03 meters per second, equals my initial, which in this case is now a negative 30. So it's going to help me get to the bottom faster here, so we should have a lower time, plus negative 9.8 meters per second squared times time. If we solve for t equals 1.126 seconds. And the problem asks for how much later does the red ball hit than the blue ball. Well, that would take our 7.24 minus our calculated value, 1.26 for the other ball, and you get approximately 6.12 seconds. And that's our answer for part B.